Have you ever looked at a third grader's math homework and just wondered, how does this all fit together? Well, today we're going to dive in and crack that code. We are going to uncover the surprisingly cool connections between a few key ideas, and trust me, you might just see the world a little differently by the end. So let's start with this: rulers, pizzas, and stop signs. I know, at first glance, they seem totally random, right? But the answer to how they're connected reveals something fundamental about how we understand our world. And to find that answer, we're going to start with something you probably have on your desk right now. Just look at this pencil. If we only had whole numbers, 1, 2, 3, 4, 5, we'd be stuck. It's clearly not 4 inches, but it's not 5 inches either. If we just say 4, we're missing the most important part of the story, the part that happens in between the numbers. And that one little idea right there is the key that unlocks everything else. So, to tell that story right, we have to officially move beyond whole numbers. I mean, for centuries, math was pretty much just about counting things one by one. But the second we started to really explore the space between them, a whole new universe opened up. This is a major, major upgrade in how we think. This whole thing kicks off by developing what we call spatial reasoning. Now, that sounds fancy, but all it really means is your brain's ability to see and understand the world in 3D. How things fit together, how big they are. And the very first tool for becoming a master at that is learning how to measure things well. So let's talk about the art of measuring. You might think, hey, I've got this down. But there is an incredibly common mistake that honestly most adults make all the time. Let's see if you know what it is. In third grade, we learned to measure 3 main things. First, there's length, how long something is. Then there's weight or mass, how heavy it is. And finally, liquid volume, how much space something fills up. It's like baking a cake, right? You need the length of the pan, the weight of the flour, the volume of the milk. It's literally how we describe the physical world around us. Okay, so back to that mistake. Take a second and really think about it. What is the absolute #1 slip-up that people make when they grab a ruler? Yep, this is it. So many of us line things up with the physical end of the ruler itself, not that little line that marks 0. And look, it seems like a tiny thing, but if you're an architect or an engineer, being off by just that little bit could cause a huge problem. Precision is everything. And this need for precision, for describing things exactly how they are, it basically forces us to invent a whole new kind of number. A number that can live in that space between the whole numbers. And that brings us to the wonderful world of fractions. You should think of fractions like a magnifying glass for numbers. They let us zoom right in on that number line and see all the incredible detail that whole numbers just completely skip over. It's like learning a whole new language to describe the world more accurately. And you know what? It's a pretty simple language to learn. Let's go back to that pizza from our puzzle. The bottom number, that's the denominator, is just how many total slices the pizza is cut into. The top number, the numerator, is how many of those slices are yours. That's it. Top is how many you have, bottom is how many there are in total. Now, what's really fun is that we can actually see fractions in a few different ways, depending on what we're talking about. So let's take a quick look at the 3 main ways we do this. First up, you've got the one everyone remembers from school, the classic pizza or pie model. This is where you take one whole thing and you slice it up into equal pieces. It's a great place to start because it's just so easy to picture. But the whole doesn't have to be just one object. Imagine you have a bag of 10 marbles, and 3 of them are blue. Well, then 3/10 of your marbles are blue. In this case, the entire group of marbles is the whole. And here is where it all comes full circle. The length model brings us right back to our good old ruler. It shows us that fractions are literally the numbers that fill in those gaps. They are the little marks between the 4 and the 5 that told us the real length of that pencil. See? It all connects. So, now that we have this new language for all the in-between parts, we can start to do some pretty powerful stuff with it. Like, for example, comparing 2 fractions to figure out which one is bigger. And this is where it gets really useful. Let's go back to our pizza analogy. Okay, you have one pizza. In one situation, you share it with 2 friends, so 3 people total. You each get 1/3. In another situation, you have to share it with 7 friends, so 8 people total. You get 1/8. Now, if you're hungry, which slice are you taking? Yeah, it's a no-brainer. This leads us to a super useful rule that can feel a little backwards at first. When the top number, the numerator, is the same, the bigger the bottom number gets, the smaller the piece actually is. Just remember this little rhyme. The bigger the bottom, the smaller the piece. Now, this might seem like a small thing, but it's actually a huge idea. It shows us that fractions aren't just stuck in place. They're like building blocks. You can take them apart and put them back together in different ways. And learning this skill is the absolute foundation for being able to add and subtract fractions later on. Okay, what a journey, right? We started because we needed to measure a line really precisely. That forced us to understand the fractions that live on that line. So now, for the final piece of our puzzle, let's take those lines and see what happens when we stick them together. This is where we get into the beautiful world of geometry. We're going to talk about a special family of shapes called polygons. Just think about the shapes all around you: a window, a TV screen, a book cover. But what actually makes a shape a polygon? Well, it has to follow a few very simple, non-negotiable rules. So, a flat hexagon with straight sides that are all connected? Yep, that's a polygon. But what about a 3D box? Nope, it breaks that flat 2D rule. And this simple distinction is the key to being able to classify the entire world of two-dimensional shapes. And of course, we give these polygons special names based on how many sides they have. A triangle has 3, a quadrilateral has 4, a pentagon is 5, a hexagon has 6, and an octagon has 8. Just like that stop sign we have to obey to keep us safe on the road. And there you have it. The puzzle is complete. We started with a simple ruler, which created the need for fractions to measure things precisely. Those fractions filled in the gaps on our number line, and then we used those very lines to build the geometric shapes that make up our world. It's such a beautiful, connected story. So let me leave you with this. Take a look around you right now. How many different polygons can you spot?